Okay, year 11 method class. So this is our second video about series. This time we are going to talk about geometric series. Okay, still remember what do we mean by series? A series is a sum of sequence, right? A geometric series is a sum of a geometric sequence. For example, we know that 1, 2, 4, 8, 16 is a geometric sequence, right? Because the common ratio with common ratio 2 every time times 2, then Sn, for example, I'm going to say S6 is a geometric series for the first 6 terms. That will be 1 plus 2 plus 4 plus 8 plus 16 plus 32. So that's what we call a geometric sequence, or for the first 6 terms. Okay, let's have a look. Okay, so here we have two formula for geometric series. Actually, they are the same. Okay, for the first one, you see that T1 is the first term times the bracket R to power n. R will be our common ratio, R to power n minus 1. N is the number of terms in the series divided by R minus 1. For the one on the right hand side, you just work that's Rn minus 1 with 1 minus Rn. Of course, the numerators are different by swapping the two terms. But then, if you see that's a denominator, it also changes from R minus 1 to 1 minus R. So that means both denominator and numerator has changed. So in that sense, actually the two formula are the same. Okay, you might use whatever you want, but you need to be consistent. If you use R to power n minus 1, then in the denominator you must have R minus 1. Okay, so I need to, possibly you are interested in the explanation of the formula. Okay, oh, yes. Sorry about this, I just spelled a typo. Okay, so just sorry, it's explanation of the formula for geometric series. Okay, so let's write a general expression for a geometric series. For geometric series, we understand that the first term will be T1 plus T2, right? But how about T2? T2 will be T1 times R. How about T3? It will be T1 times R to the square, right? And we have up to n minus 1th term, so Tn minus 1. That means n minus 1th term. So for this one should be T1 times n minus 2, right? And for the last term will be Tn. So Tn is here, so Tn will be T1 times R to power n minus 1. This is just the formula for geometric sequences. So if you remember the geometric sequence, the general term, we use the explicit rule. Tn equals T1 times R to power n minus 1. Okay, so that's Sn. So let's have another one, which what we call another version. So this time we multiply minus R to Sn. Okay, if we multiply that minus R to Sn, what happens? Then every term on the right hand side would be multiplied by that minus R, right? For example, for the first term it becomes minus T1R. For the second term it becomes T1R squared, because originally it's T1 times R. Now it becomes T1 times R squared, T1 3, okay, T1 R. So when you multiply, sorry, it should be minus. When you multiply R becomes n minus 2 becomes n minus 1, and the last term becomes t1 times r to the power n. Okay, so what happens here, you can see this term looks the same as this term, right? And also this term looks the same as this term, all right? And also see this term, as we put that, looks the same as this one. All right, so let's say if we add them together, if we try to add them together, okay, what happens? Okay, so on the left hand side is Sn plus minus Rsn, then becomes minus Rsn, right? On the right hand side, T1 is here, but T1R would be cancelled by that minus T1R, okay, and T1R square will be cancelled by that minus T1R square, and by the same by applying the same pattern, you will expect that T1R cube will be cancelled by something here. All right, so and when we looking at the end of the expression, you will expect that T1R to the power n minus 2 will be cancelled by something here. All right, and of course the last term T1 times R to the power n minus 1 is cancelled by the term here in purple circle, right? So, but the last term will be intact, it won't be cancelled out, right? So, what we left behind, okay, what we got now is T1, the first term of the first line, and the last term of the second line. That's what we have now, all right? And then, let's say, for the left-hand side, we could take out that Sn as a common factor and becomes 1 minus R. For the right-hand side, you might take out that T1, it becomes 1 minus R to the power n. Okay? And you can divide that 1 minus R to the right-hand side. And that's what you get. Okay? Alright? So, after this, you can see this is the formula of one of the two versions. This is the second version, right? But as I have said, the two versions are equivalent, so that means we have proven that the formula for geometric sequences, for geometric series. Okay, is that all right? Okay, so if you are interested in this, you might spend some time on understanding this, but at least for all of you, you need to know you can apply this formula now for a question. Okay, right? Okay, so we are going to do example 1. For geometric sequence 1, 2, 4, 8, calculate the sum of the first 6 terms. Okay, the sum of first 6 terms. So what does it mean? It means S6 equals 1 plus 2 plus 4 plus 8 plus, so there are only 6 terms, so we don't mind writing all of them. Okay, of course you can use a calculator, but since we have just learned the formula, let's try to use the formula. In this case, T1, that's the first term, will be 1, and R should be, you can use second term divided by first term, or third term divided by second term. Got 2, okay? So let's apply the formula this time. 1 times 2 to the power 6 minus 1, and 2 minus 1, okay? So for this type of question, since the numbers are quite simple, so you might not be allowed to use calculator. That means this question will be in paper 1, okay? So you might need to do a bit of calculation by yourself, okay? And that will give you 63. Of course, you can add the numbers together. You can see that actually the answer would be the same. All right. Okay, so let's move on to another one. Okay, so that would be our example 2 for the geometric sequence 81, 27, 9, 3, 1 over 2, 4, 3. So you see the number getting smaller and smaller, and there's still a common ratio, because for 81 to 27, you times 1/3 or divide by 3. From 27 to 9, you divide by 3 again. So that means this is a geometric sequence with common ratio less than 1, which is 1/3, right? Okay, so first of all, you need to find how many terms over here. That means the number of terms, okay? Okay, the number of terms, okay? Okay, what kind of formula do we need to use to find the number of terms for a geometric sequence? Do we need to use the new formula? No, that's for series, okay? For sequence, if you are going to find the number of terms, that's a formula I have learned and I've been using for quite some time. Okay, so we use this formula, if you remember, okay, Tn equals T1 times Rn to the power n minus 1. So Tn will be our last term. T1's 81. R will be, in this case, okay, so let's try R will be 27 over 81, 1/3, right? So R will be 1/3, okay, n minus 1. So you need to find n, okay. How could we do this? All right, so let's say, okay, if you are going to do this using calculator, that's okay, right? But if that's paper 1, could we do this? Okay, you might try the power of 3, because if this question is in paper 1, that means all the numbers should be in the power of 3, okay? Otherwise, it would be impossible to find, okay, by not using calculator, okay? So if assume this one is a paper 1 question, what are we going to do? Try to think about the power of 3, okay? Let's have some look at the power of 3, okay? Of course, 3 squared equal to 9, 3 to the power 3, 27, 3 to the power 4, 81, 3 to the power 5, 243. So do we see 243 here? Yeah, so that means that's the 3 to the power 5. Okay, how about 81? 3 to the power 4. And here's unknown, but we know that you can put that n minus 1 over here and n minus 1 over the numerator, right? But since that's 1 to the power of something, so it's still 1, okay? So we don't need to worry about this. Okay, so how about the things on the left hand side? If we want to write it into an index form, that's what we're going to do. 3 to the power minus 4, and here's 3 to the power 4 times, okay, that's 1 to the power something is still 1. And since that's on the denominator, we will have this one. If you remember, just 1 over something to the power becomes that thing to the negative of that power, okay? So that means we have minus 5, 4 minus n. If I remove the bracket now, it becomes plus, right? Okay. Let me create a bit more room for sorry to change that. More room. Okay, so since both have a base 3, so you will have minus 5 equals, right hand side becomes 5 minus n. Okay, so for this one, n will becomes 10. Okay, so that means the number of terms, there are 10 terms. Okay, right, so here's a bit of exercise on index law. So how about the sum of the terms? So you need to find the sum. Sum means a series, right? So there are 10 terms as 10, okay? And you are going to do first term 81 times, okay, 1 over 3. So because that's R, okay, possibly I need to code that rule again here, so it will give you a better picture of what we are going to do. Alright, so let me put the formula just right here, so you could have a reference. Okay, so we have this one, oh sorry, that's 10 minus 1. Okay, alright, so for B part like this, so I think since there's 3 to the power 10 is quite big, so for question like this it should be in paper 2. Okay, of course you could challenge me that part A could be section paper 2 as well. Just treat A like a question in paper 1 and B like a question in paper 2. Okay, so you might use your calculator for that, so I'm not going to spend much time on the calculator thing. I think you would be alright, right? Okay, so you might just use your calculator. Let me track the answer. Okay, so give me a bit of time, I get the answer for you, right? Okay, here's the answer, right? Okay, so for this part you need to use your calculator. Alright, okay, so let's move on to another question. This one will be quite similar to the first one, so possibly I'm going to allow you to spend some time, like you should spend like 5 to 10 minutes on this one. Try to use the same approach like we have done before. Very similar skills, if not the same. Okay, try to do this one. Okay, and then we are going to check our part A answer. Then I'm going to give you further time on B, and we're going to check the answer of B as well. Alright, okay, you come up to this step, and there's some problem because that's minus 2187 is quite big, so you might still think that would be our power 3, right? So if you goes on, actually you will get that power 3. You will get that would be power of 3. Okay, but it just becomes so difficult, so possibly we might use calculator. To solve this one, you need to use your calculator. You need to, okay, so the idea would be like this. You need to, let's say, you need to define in your calculator, define this fx equals, minus x to the power x minus 1. Okay, is that n you need to change into x. That's what happens in the calculator. And then you put in different numbers into x until you got minus 2187. Okay, so that's what we are going to do. Let me show you how to do it. Okay, so, oh sorry, I got it wrong. Okay, let's go out. Okay, so it must be calculator, and you go to menu, you go to action, you got define. Remember, define function must be f bracket x equals, okay, still remember the function, minus 3 to the power x minus 1. Okay, change that n into x. Okay, you have to type everything. Okay, if you just type that's minus 3 to the power x minus 1, the calculator won't understand. Alright, so then I'm going to substitute different numbers. For example, if I think that's minus 2187 is quite a big number, so possibly I start with 6. Okay, so it's minus 243, it's quite far away still. Let me do it like 9. How about that? Okay, then it becomes bigger than that. Also, this becomes a positive number. So I'm going back. Sorry, going back using 8. Okay, so here's the answer. Okay, So do we need to worry that the answer will be decimal number like 8.5, 7.3? No, because we understand that n is the number of terms. Okay, and so the answer must be an integer, so that's why you can try one by one. Okay, so that's why you got 8 as your answer, right? Okay, so and then we're going to the sum of the terms. Okay, again, I'm going to give you some time on that. Okay, so that will be the answer. Okay, all right, so no problem. Just sub the numbers according to the formula. Remember that power n will be 8, not a minus 1. Don't confuse the formula for the series with that formula for the sequence. Okay, let's look through another one. So this one is also simple and familiar. For geometric sequence like this, calculate the sum of the first 10 terms. So this part would be easy. Okay, so again, we are going to use this formula. Okay, and T1 equals 2 R. When you are going to find R, use second term divided by first term, you got 4. Okay, and of course, you are going to find the sum of the first 10 terms. N equals 10. Okay, so S10 equals T1, 2 times 4 to the power 10 minus 1. Okay, so it's divided by 4 minus 1. Okay, so I will save you the trouble of using calculator. So it just equals this one. Okay, you must use calculator. The number of terms if the series is, so part B, you're going to, again, like what we've done before, you're going to find that power n. Okay, so this time we're going to say 43690, that's Sn. First term still 2, 4 to the power n, because it's about the number of terms. You need to find n, minus 1 equals 4 minus 1. Okay? Okay? So, if you like, you can do a little bit simplification. Okay? You could do a little bit simplification. But if you don't want to do any simplification in paper 2, that's still okay. But you might lose some mark. Okay? So, I would try to do some simplification before we actually go for the calculator, right? So you will have 3 on the denominator. You are going to multiply that 3 to the left hand side, and also you are going to divide that 2 on to the left hand side as well. Okay, so that's what we are going to do. I multiply 3 because that's the denominator on the right hand side is 3. I'm going to divide by 2. I'm going to have 4 to the power n minus 1. Okay, use your calculator to do the calculation on the left hand side, and then you plus 1 to that left hand side. You will have 4 to the power n equals this one, 65536. Okay, then all you need to do is find integer n. Of course, in the calculator you could just put numbers into the power into n, so until you get the answer, right? Okay, so but I just try to use calculator again. Let's define that fx equal to 4x, right? Let's do it again. Okay, so that's last definition. This time I'm going to change it. Oh, sorry, I need to use copy and paste, but I'm going to change the content. Okay, so this time it's like this, 4 to the power x. Okay, and I just substitute different numbers. Okay, for example, if I'm going to substitute 6. Okay, 4090, is that okay? No, that's far away because you need 65,536. Okay, so since that's too far away, let's try 8. Okay, you got it. So that means our answer would be n equals 8. That's it. Okay, so it's time for you to try this one using basically the same skills and procedure to solve A and B. Okay, I'm going to give you some time. Okay, so that will be our first answer, right? Okay, let's see how could we do B. Okay, so that's how we get the answer, right? So I know some of you might not get the answer. You need to check my writing very carefully, especially some of you might miss that bracket. So that bracket here is very important. The bracket in the denominator, I mean this bracket, is not that important. If you miss that bracket in the denominator, that would be fine. But if you lost that green bracket, that would be wrong. Okay? Remember this. You might use your calculator to see what happens if you have that bracket and then power 8, or without it and power 8. The answer would be just one positive and one negative. Alright? So that's one of the reasons. Okay? You need to be careful. Alright? Good. And that's for the simple and familiar questions. Okay, so let's see example 4. Okay, so example 4 will give you two conditions: T3 equal to 16, T6 equal to 128. Find the sum of the first 10 terms. Okay, so if you remember that I've taught you one general formula for between two particular terms in a geometric sequence, right? So we use this one. So if you are going to find Tn given Tm, what you need to do is to times r to the power n minus m. Okay, so this one will be quite useful here because I give you T3, T6, so that 6 will be our, suppose n, this will be our n, alright? Okay, so let's see what happens. So let's say n is 6 and m is 3. R is what we're going to find because you need that R for that's the sum of the first 10 terms, alright? So, and that's 6 minus 3, okay? Then we could substitute in the numbers. Okay, then you will have this one. Now, of course, you see that will be 8. So, for a number which you got power 3 equals to 8, then R must be 2. That's it. So, you've done that. Okay, then we're going to do next one. Find the sum of the first 10 terms. Okay, sorry, we haven't done it. We need to find T1 as well, alright? How could we find T1? Okay, so we use another formula. T3 equals T1 R squared. T3 is 16, and T1 is what we're going to find. R is 2. Okay, so by doing this, you know that T1 will be 4. Okay, then we are going to find S10 eventually. S10 would be T1 times R to the power 10 minus 1 over R minus 1. T1 is 4. 2 to the power 10 minus 1. 2 minus 1. Okay, so the answer will be this. Okay, that will be our example 4. Okay, you see, you need to use your knowledge in sequence to help you to find two major quantities in our formula of geometric series. You need to find R, you need to find that T1. Okay, so that's two essential components in that formula. Okay, let's move on to this part. Okay, so I'm going to give you some time to do it. So remember, when you see the something negative and sometimes positive, then you know you will expect that the common ratio will be a negative number, right? Okay. Okay, so here's the answer. Okay, so first you need to use T7 equals T4R to the power 7 minus 3, and you get that substitution done, and you move the term to the other side. You got R equals to minus 1/5, and then you need to find T1. Remember, you need to find R, you need to find T1, then you got the enough components for that's S to power 8. Okay, again, bracket is important here. You need that bracket for the calculator, and if you use your calculator properly, then that will be the answer. Alright, okay, that's it. Okay, so here's our last question, which is complex and familiar. Okay, in a 5-day cycling tour, Jack must ride 100 kilometers on the first day, and each successive day he rides 90% of the distance of the previous day. Okay, so that sounds like a geometric sequence, right? 100 km first day, 100 times 90% second day, and 100 times 90%, another 90% the third day. Okay, calculate the total distance Jack rides for the whole tour. Okay, so let's see. The 5-day tour. So that means n equals 5. Okay, so how's the sequence looks like? Okay, just think about the sequence. Okay, the first day you got 100 km. Second day 100 times 0.9, that's 90%, just easier to write. Okay, third day should be another 0.9, but I just squared. Okay, etc. Okay, so that means that this is a geometric sequence, right? And total distance means you need to add all the terms up. Okay, up to 5. Okay, so S5 equals 100 plus 100 times 0.9 plus this one, etc. But what we're going to do is to use the formula. So 100 is T1, right? And you got 0.9 square, to the power 4, to the power 5, about that, S5 minus 1, and 0.9 minus 1 to get the answer. And so let me track the answer. Okay, so that should be I can't find the answer. Okay, give me a moment. Give me a while. I'm coming back soon. Okay, so here's the answer. Alright? Okay, so another question is how many days? How many days will Jack have? Okay, ridden at least half of the distance. So part B is about how many days. So that means you need to find n. Okay, so let me move this a little bit down so I got the space. Alright, so for this one, for part B, what you are going to do is to find the distance you are going to ride. Okay, Jack is going to ride. Okay, so the distance would be we don't know n, but we know the total distance will be Sn, will be S5 divided by 2. So you use this one divided by 2. Of course, you are going to use calculator, right? Okay, so that's the distance you are going to write. Okay, and then you are going to solve it by using the formula for geometric series, which will be 100 times 100 is t1, 0.9 to the power something n, which we don't know, minus 1. Okay, so that's 0.9 minus 1 equal this one. We are going to solve this one. Okay, so remember that's how many days we'll check. Okay, so need to find the number of days, and number of days is n. Okay, of course you are going to simplify this expression a little bit before you can solve it. Okay, let's see. Okay, so the denominator will be minus 0.1. Okay, so that will be minus 1000 on the right hand side. Okay, so basically you will see this thing. Okay, so and then you plus that one to the other side, you have this one. Okay, so again you are going to use that calculator function. You define fx as 0.9x. Okay, then you put difference x into the formula until you get very close to this one. But remember, you need to rounding up the final answer, right? So when you use your calculator for this, you see you for the calculator. Okay, let me show you how to do it. Okay, so let's define another function. Let's define another function. This time we are going to do this, and that's 0.9x. 0.9. Okay. Right, so let's put number into it. So let's put 2. 0.81. Is that okay? Yep, because you need to equals to this one. All right, but you need to okay, you need to come. Okay, so we need to find such an n that will give a value which is close to this one, right? But the problem is whether we should have value less than the number or greater than, because it's impossible to have an exact value now. All right, so let's use our calculator to check. Okay, so that's our previous one. I'm going to compare this function, which is 0.9 to pi x, to the previous function 4x, right? Because they are quite different in terms of their behavior. Okay, so let's say this time I change that to 0.9. Okay, so we define it. So let's see what happens if I put value 1. So 0.9, that's okay. So you see when I put 2, so when x becomes bigger, so the result becomes smaller. So that means it's different to the previous one, because for the previous one, when the base is full, and when you put x into the power, greater the power, the greater the result. But here, when the base is something less than 1, greater the power, the smaller is the result, right? So you see now we are going to have something which come close to 0.79, but we know that we need such an n which that makes sure you can finish the journey, right? Okay, So let's see, when we got F2 0.81, which is still greater than that's 0.79, and we shall not use that 2 because we know that's the bigger the index, the smallest the result, right? So let's see, 3, okay? For 3, you see there's 0.72, which is less than this one. So we understand that n should be 3 instead of 2, okay? Remember that when the base is greater than 1 or the base is smaller than 1, they are quite different in terms of their behavior. Okay, so let's see the last one. Okay, so this is the last question, which is, I think, should be complex in terms of level. Okay, mathematical method students for North Mackay State High are required to make hand sanitizer to fight against the spread of COVID-19? Yeah, that's such a good question for current circumstances, right? I think that's a typo. They make 2 liter on the first day, and each successful day the production is increased to 1.2 times of the volume they produce in the previous day. So that means every day they will increase their production by 1.2 times the previous day's production, right? Calculate the total amount of hand sanitizer they produce in 1 week. Okay, so this question quite similar to the previous one, so I might give you some time to try. Okay. Okay, so here's the result. You see, this one's still a geometric sequence. We got 2L first term, 2 times 1.2L because they increased their production by 1.2 times each day, right? And the third day is increased by another 1.2 times. Okay, so this looks like perfectly like a geometric sequence. Alright, so for the sum total amount in 1 week, so that means 1 week there are 7 days, so that means S7. Okay, then you put all the numbers into the formula and you got that number. Okay, if you get it, that's good. Okay, for B, just try to use the previous method, but this time you need to guess what number of day it is. Okay, so that's what you should have. Okay, so this time n is the unknown which you are going to find, and you just put all the number to the right hand side. So you will have 1.2 to the power n equals 4. Okay, so and then you should define the function fx equals 1.2 power x. You need to find x such that this will satisfy the not satisfy, you need to get past that 4. all right, okay, because that means the number of days that they can produce 30 liters sanitizer, so that's why it's not equal, but you need to pass it. Okay, so I define the function here. So when you compare to previous question about the cyclists, so this question, the base becomes 1.2, which is greater than 1. Okay, so let's see the behavior of this function. So when I put 2 into it, so it's 1.44, right? Put 3 into it, 1.7. So again, for this one, it's unlike the previous one. Greater the x, greater the power, and greater the result. The previous one, since the base is less than 1, greater the power, smaller the result. Okay, so you are looking for something which can pass that 4, right? So you keep input. Okay, still not there. So run out of patience. Okay, all right. Okay, so I think we might go a little bit quicker. Okay, 7 still not there. Let's say, how about 8? Right, so when 8 is past 4, so when 7 still less than 4, okay? So the conclusion is n need to be 7. Okay, so 7, sorry, let me see. Sorry, 8, oh, sorry, that's wrong. Okay, because at day 8, sorry, I made a mistake. So I just forgot. Okay, so let's see this again. F8 greater than 4, F7 still less than 4. Okay, so that means it takes 8 days. 8 days. Alright, that's it. Okay, so for this video, uh, which we have learned what's geometric sequence. Okay, geometric series, which is from the summation of geometric sequence. Okay, we know the rule. Okay, and we know how to combine our knowledge in geometric sequence and to help us to find the sum of first few terms. Okay, so the main challenge will be in the case that you need to find the power n. Okay, like the question here, need to find the power n. Okay, so that would be the complex familiar or complex unfamiliar. Okay, the next video will be about the infinite series of geometric sequence. Okay, see you next time.